All right, today we're going to do a lesson on translations and rotations on a coordinate plane. And you've already talked about translations and rotations without coordinates, but once we stick it on a coordinate plane, we get some rules that we can use and things get a little bit neater. So in general, right now, you should know that a translation is a slide of an object a certain distance in a given direction. Okay, and that certain distance in that given direction is your vector. Okay, and our vector is, it kind of tells us it's kind of down and to the right or straight over to the right, straight up, things like that. Now, when we put that on a coordinate plane, translation notation gets really nice. Translation notation is TAB, where if you were given a vector AB, it would look like that. But when we talk about coordinates, we get things like T 2, 3 or T -1, 3. When you see numbers down here, this tells you how much to go right and left and how much to go up and down. So T 2, 3 means 2 units to the right, and the 3 means also go 3 units up. If I see T -1, 3, that means 1 unit down and 3 units up. Okay? So these numbers represent your up and your down for translation notation and your left and your right. So if I have this, use the rule x, y, arrow, x plus 7, y minus 1, that's considered vector notation. If I call that vector notation, what I get with that is I really get a translation. X plus 7 means go take your x's and increase them by 7. Well, if I can increase x by 7, that means I'm moving 7 units to the right. And if I decrease y by 1, that means y is going down by 1. So this is going to be -1. So this is the rule in standard translation notation. And now we're going to do that. So I'm going to take this point and I'm going to go 7 to the right and 1 down. So 1, 2, 3, 4, 5, 6, 7, and then 1 down. And that gets me L prime. And then N, 1, 2, 3, 4, 5, 6, 7, 1 down. There's N prime. M, 1, 2, 3, 4, 5, 6, 7, 1 down. There's M prime. And then I got my points right there. Now, to get my coordinates, I can actually do one of two things. I can either grab the coordinates right from the image and say, well, L prime is at 1, -2. Or I can also get those coordinates using the rule. This says take x increased by 7, y goes down by 1. So this is the point currently, if I could write appropriately, this point is currently the point -1, -1. And if I increase x by 7, I get to 6. And if I decrease y by 1, I get -2. And this is 6, -2. And then last but not least, m prime is going to be 3, -4. All right. So there you go. There's a translation image. This slid down, and I'm good to go. State the coordinates of ABC, then graph the image under this translation. State the coordinates of the image. I want you to try and do that on your own, and then come back and we will talk about it. So hit pause right now on your YouTube. Do this one on your own. When you hit unpause, I will have brought it back up here on the screen. So hit pause. Hit pause right now. All right, hopefully you've tried that on your own. So here's what I did here in the meantime. Here's triangle ABC. -1, 2 means move it to the left. Come here. Move it to the left 1 and up 2. And that's where my new triangle ended up. So my original coordinates were right there. My new coordinates are right there. All of the x's decreased by 1. All of the y's increased by 2. And there's your new graph. All right, so next one, example 3. We want to figure out how did ABC become A prime, B prime, C prime. So we're just going to look at it and see what happens. So if I grab this point right here, it went 1, 2, 3, 4, 5, 6 to the right, and 1 down, which would be 6, -1. That's it. That's all you have to do. And then last but not least, I want to talk about this one. One translation rule that's equivalent to the composite transformation t negative 3, 4 and t 2, 3. Now, one thing that's important to note, when you see this little O notation, I like to call that following notation. And what it really means is that you go right to the left. So we do a translation of 2, negative 3, and then do the translation of negative 3, 4. So if I went right 2, down 3, and then went left 3, up 4, what's my net difference? Well, I went right 2 and then left 3. I really moved to the left 1 from my original position. 2 plus negative 3 is negative 1. And then down 3 and up 4 really just went up 1. 4 plus negative 3 is 1. All right, so that's translations. Now rotations. A rotation is a turn of a figure about a fixed point. And that fixed point is your center of rotation. Rotation notation, which is hard to say 3 times fast, is R, and then usually like a C for the center of rotation, and then like the number of degrees you're rotating, RC 60 or RO 90. Okay? Rotation notation tells you your center of rotation, and then it tells you the angle of rotation. Remember, this angle, if it's positive, means you go counterclockwise. If it's negative, you go clockwise. And one of the other things that sometimes you see is you won't see a center of rotation, and it'll just say R270. That usually indicates that the origin is your center of rotation. So if you don't see a center of rotation listed, like in this one, you can assume that the center is the origin. Now, rotations, we're going to do some kind of funky turning stuff here, so kind of bear with me. So the first thing we're going to do is we're going to draw Dan, 417358. So you draw Dan, I'll draw Dan, and then you can hit play. All right, welcome back. Here's Dan. Now, I'm going to do something a little crazy. We need to rotate Dan 90 degrees, and you are going to turn it by turning your paper. So I'm going to take my paper right here, and I am going to turn my paper 90 degrees counterclockwise. So there it is. Now, I need to look at Dan again and figure out where he ended up. So now, Dan, if I look at this new graph as being here's X, here's Y, Dan moved from where he was in the first quadrant over here to the second quadrant. So Dan ended up, and I'm going to write these kind of sideways, so bear with me here. Dan ended up left 1, 1, 2, 3, 4, up 4. So Dan is now at the point, and yes, I'm writing sideways, negative 1, 4. And that's his image. So that's a D prime. The next point A is 1, 2, 3 over, 1, 2, 3, 4, 5, 6, 7 up. So A is negative 3, 7. And then N, again prime, I forget my primes here, N is now 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5. N is negative 8, 5. So what I just did is I turned Dan, I figured out where he ended up, I wrote out the new coordinates of Dan, but now I need to come back and actually plot the new Dan. I need to plot Dan prime. So I'm going to take a second here. I have to Control A, group all those. I'm going to back out. I'm going to take my page. I'm going to rotate it back to where it belongs. And you should be doing this too. And then I'm going to look at Dan again and say, all right, Dan's back to where he was. Now I need to plot the new Dan prime. So I got to come back here, and I'm going to plot Dan prime. So negative 1, 1, 2, 3, 4. There's D prime. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. There's A prime. And 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. There's N prime. So Dan rotated 90 degrees about the origin, ends up over there. And if you look at it, you can see it. And remember, from what you already know about rotations, if I connect the pre-image and the image, I'll do it with crayon so it's not too dark here. If I connect D prime to the center of rotation and then to D, there's a right angle. If I do the same thing with N, that to that, I have another right angle. All right, so that is a rotation of 90 degrees. Now we're going to rotate negative 90. So I want you to try to do this on your own. So what you're going to do is you're going to take the same paper, you're going to turn it 90 degrees clockwise, because that's negative 90, 90 degrees clockwise, right down where Dan ends up, not Dan prime, but right down where the original Dan ends up, which should be down here, and then plot the new Dan. So take a second, turn your paper, we're going to pause, turn your paper, put him where he ends up. All right, so welcome back. So what you should see now is your graph should look like this. Dan ends up down here, and then the coordinates for Dan are 1, -4, 3, -7, and 8, -5. Now we're going to develop a rule. So notice, D originally was 4, 1. After a turn of 90, it became -1, 4. So I have the same numbers, but in a different order, and one of them's negative when it wasn't. 7, 3 became -3, 7. 5, 8 became -8, 5. 4, 1, 1, 4. We swapped the order. So XY swapped and became YX, and the first number became negated. So -YX. Now, when I turn -90, which is equivalent to a positive 270, because if you think about it, all the way around is 360, right? So if I go 90 this way, it's the same as going 270 the other way, because 90 plus 270 is 360. These are known as what's called coterminal angles, -90 and 270. So I have a rotation of -90, which is the same as a rotation of 270. 4, 1 became 1, -4. So again, I swapped Y and X, but now the second one got negated. Okay? All right, we're going to come down here, last one, and we're going to do rotations of 180. So take a second, plot peg. All right, so you should have plotted peg. Peg should look like this. Now I'm going to rotate peg 180 degrees. So 180 degrees really turns it upside down. So I'm going to turn it upside down. Now I'm going to look at my new coordinates, and I'm going to say, okay, now P ended up left 3, up 1. So P prime is going to be -3, +1. Yes, I'm writing upside down. And E prime, E ended up, let's see, 1, 2, 3, 4, 5, down, 1, 2, 3, 4, 5, 6, 7. E ended up at -5, -7. And then G prime ended up at, well, let's see, it went all the way over 9. So -9, 0. So there's peg. And now let's see, what did that really look like here? If I flip it back up, okay, and I look at peg again. So my new coordinates are -3, 1, -5, 7, and 9, 0. I want you to take a second, plot those 3 new coordinates. Plot them right now. All right, so your peg should look like my peg. We turn peg upside down 180 degrees, okay? And new peg prime looks like that. All right. Now, if I'm going to state the rule here, what happened? I had original peg had 3, -1, and new peg is -3, 1. 5, 7, -5, -7. All we did is we left the x's and the y's in the same place, but they each got negated. Okay. Now, this rotation of 180 degrees, I should be able to tell that because if I connect P with P prime, it should look like a 180 degree angle. So there's P to the origin, and then P to P prime. There's a 180 degree angle, right? Because it's a straight angle. Well, because this is a straight angle, it actually has another meaning too. A rotation of 180 is the same as a reflection through the center of rotation, or in this case, the origin, because it's kind of like the P got sucked into the center of rotation and spit out the other side. E got sucked into the center of rotation and then spit right out the other side. So a rotation of 180 is the same as a reflection through the center of rotation. All right, so what did you learn in this lesson? You learned that a translation of AB means A units left, right, okay, and B units up, down. Something is going to the left if A is positive. It's going to the right if A is negative. Wow, I did that wrong. I said that completely wrong because I'm writing and talking at the same time. A unit's left, pardon me, left means you're going, you have a negative A, right you have a positive A, up you have a positive B, down you have a negative B. And then if we have a rotation around a center point a certain number of degrees, these have rules. A rotation about the origin of 90 degrees takes XY, swaps them, and negates the first one. A rotation about the origin of 180 takes XY, doesn't swap them, and just negates both. And a rotation about the origin of 270 degrees, which is the same as negative 90, takes XY, swaps them, negates the second one. All right, so translations and rotations on a coordinate plane, there you go. I hope you learned something. I know I sure did. Good luck in class.